Hello everyone, welcome back to my organic chemistry mini lecture. I have already talked about the naming of acyclic compound in another mini lecture, and today I will talk about the other part of the lecture is the naming of cyclic compound. And first, I will talk about the cycloalkanes. This is one example. This is the bromo group, and this is the cyclopentane. If there's just one substitution, then you just say bromo cyclopentane. You don't have to number it because this carbon connect to the only substitution will be always carbon 1. So you don't need to say 1 bromo cyclopentane. Okay. Now if you have a 2 substitution, then that's a different story. This is the parent is a cyclohexane, and you have a methyl group and a chloro group here. If you remember the rule of numbering, you want the lowest number, so you can number this as 1, then this 2, that's 3, 1, 3. If you number this is 1, that's 2, that's 3. It's also 1, 3. That's a tie, just from the numbering of these 2 substitution. Now, how to break the tie? We don't have any other way to break the tie, so the only way is alphabetic order. So we have the chloro, methyl, so the chloro start with C, methyl start with M, so chloro will be number 1. The carbon connected with chloro will be numbered as 1. Okay, then that's 2, that's 3, then 4, 5, 6. So the name will be 1 chloro, 3 methyl cyclohexane. Another example, we have a 3 substitution, 2 methyl group, 1 ethyl group. In this example, we don't need to use alphabetic order to break the tie because there's no tie. Here, we're gonna number this as 1, 2, 3, 4. That's the correct numbering. And you don't want to number this as 1 because then there will be 1, 2, 3, 4. That will be 1, 3, 4 instead of the 1, 2, 4. So this will be lower. So the name will be 4-ethyl 1,2-dimethyl cyclohexane. So why do you have to put the ethyl first? Because alphabetic order. So you have to put the different substitution in alphabetic order in the name. You have to do that. Okay. Now let's talk about the cycloalkene. So when you have a double bond in the ring, how to name it? So the core here is a cyclopentene, but you have 2 substitution. One is a bromo, one is a methyl. Since double bond have a higher priority than the alkyl group and the halo group, so we have to number one of this vinylic carbon as carbon 1. Number this as 1 because you have a bromo here, so that will give the bromo, the first substituent, lowest number. So that will be 1, then 2, 3, 4, 5. So the name will be 1 bromo 4 methyl cyclopentene. Okay, see, bromo, methyl, that's alphabetic order. Not because this is 1, this is 4, it's because the B and M. Okay, now second example, we have chloro and methyl in this molecule, 2 substituents, and double bond is here. So actually there's another tie here. So because if you number this is 1, that will be 2, 3, 4, 5, 6, 3, 6. If you number this as 1, that's 2, 3, 6. So 3 and 6 are the 2 substituents number. That's a tie. So how to break tie? Again, use the alphabetic order, chloro, methyl. So we want the chloro has a lower number. So that will be 1, 2, 3. So 4, 5, 6. Methyl will be 6. So the name will be 3-chloro, 6-methyl cyclohexene. Last example is a diene. Okay, the cyclic diene. Again, we want to give the 2 double bond low number. So we will number this as 1, 2, 3, 4, 5, 6. And you may ask, why don't number this as 1? If you number this as 1, this 1, 2, you cannot go this way. You have to go 1, 2, 3, 4. Then the first substituents will be 3 instead of 2. So that's wrong, not from here. must form here 1, 2, 3, 4, 5, 6. So the name will be 2,5-dimethyl. You have 2-methyl group, cyclohexa, and 1,3-diene. 1, 3 is the location of the double bond. 1 and 3. Okay, diene. Now let's talk about the cyclic ether. Okay, that means in the ring, there's oxygen as a member, and this is a 3-membered cyclic ether, and the name is called oxyrane, but there's a more common name. It's called epoxide. Okay, sorry, epoxide. If it's a 4-membered, and that's called oxetane. 5-member is called tetrahydrofurane, and this is a very, very common organic solvent in synthesis, simplified as THF, tetrahydrofurane. If there are substitution, you always number the oxygen as number 1. For example, if you have this epoxide, chloro substituted here, and then you have number as oxygen as 1, and then 2 here because you want this chloro as a low number, and then 3. So that will be 2-chloroxyrane. And another example, the substituted THF. So we have a methyl group on this carbon, but this oxygen must be carbon 1. Sorry, not carbon 1, number 1. Okay, 1, 2. You want methyl low number. You don't want to go here. If you go 1, 2, 3, 4, 5, the methyl will be 5. So that will be higher number. But you want a low number. 3, 4, 5. That's correct number. And then name is 2-methyl tetrahydrofurane. Now let's look at the cyclic alcohols. This is alcohol with the ring system here, and we have another substitution bromo group. Since the alcohol, the hydroxyl group has a higher priority in the naming than halo group, so this carbon always default as 1. So that's 1, 2, 3, 4. If you go to this way, 1, 2, 3, 4, that's the same. Okay, symmetric. So the name will be 3-bromocyclobutanol. You don't have to say 1 because this one is default. Another example is alcohol and amino group here. So again, the hydroxyl group is a higher priority than the amino group, so this amino group will be treated as substituents. And the numbering carbon here must be 1 because it connects to the highest priority functional group. 2, 3. So that's amino group location 3, 4, 5. So the name will be 3-amino-cyclopentanol. Again, you don't have to say 1 pentanol because this carbon is default as 1. Now, last example, we have 3 substitution on this cyclohexane, and this carbon again will be 1, and then 2. You want to give low number. Fluoro and the methyl group have the same priority, so you want to give a lower number to one of them. So if you go this way, you will give 3 here. Go this way, it will be 2. So this will be best, the correct numbering. 3, 4, 5, 6. So the name will be 2-fluoro, 5-methyl cyclohexanol. Now let's talk about the cyclic ketone. Okay, ketone is a carbonyl functional group with both carbon connection on the same carbon. And then this is a 5-membered, okay, so it's a cyclopentanol. You have 2 substitution, chloro and ethyl. And seems like there's a tie here because first, this carbon always be 1. Then you can go this way or this way. Seems like you have the same number of these 2 substituents. Then you have to use alphabetical order to break the tie. So that's 1, 2 because chloro versus ethyl. Okay, 3, 4, 5. So the name will be 2-chloro, 5-ethyl cyclopentanol. You don't have to say 1 cyclopentanol because this carbon is default as 1. And same idea with the cyclic alcohols. Another example, this have a double bond here, and ketone has a higher priority than alkene. So we still number this carbon as 1, and then 2, 3, 4, 5, 6. because you also want to give a low number to this double bond. So the name will be 2-cyclohexenol. 2 is the location of this double bond. Now you have methyl and methoxy group here. So, and this is another cyclic ketone. And again, we have another tie. So we want to break the tie. So 1, 2. We want number, this is 2 because alphabetical order, this is called a methoxy, this is methyl. So O is earlier than Y, that's why. Okay, 3, 4, 5, 6. So that's 2-methoxy, 6-methyl cyclohexanol. Now next, we will talk about the cyclic ester and the cyclic amide. Okay, first, cyclic ester is called a lactone. And this is 3-membered lactone. This carbon is called alpha carbon. Okay, this is the carbon of the carbonyl. So the next carbon to the carbonyl carbon is called alpha carbon. And that's alpha carbon. That's a beta carbon. That's alpha, beta, gamma. That's alpha, beta, gamma, delta. Okay, so that's called alpha lactone. This is called beta lactone. This is called gamma lactone. This is called delta lactone. And if an oxygen is nitrogen, that's cyclic amide. It's called a lactam. And same idea, this is called alpha lactam. This is a beta lactam. This is a gamma lactam. And this is delta lactam. And look at this beta lactam. This is actually the core structure of penicillin. Okay, the first antibiotics. Okay, so we will talk about next the aromatic ring. This is the parent of aromatic ring. It's called a benzene. Okay, and it's very stable structure because of the delocalization of the 6 pi electrons here. It's called a benzene. Now the substituted benzene, for example, methylbenzene. We don't call it methylbenzene. We call it toluene. And hydroxybenzene is called phenol. Methoxybenzene is called anisole. And aminobenzene is called aniline. And this is the aldehyde. It's called a benzaldehyde. And this is acid. It's called benzoic acid. And last one, you have a vinyl group here. It's called styrene. Okay, styrene is the monomer for a polymer. It's called a styrofoam. Okay, here are examples of more substitution. Here we have a tri-substituted benzene, and we have ethyl group, chloro group, and a bromo group. And they are actually same priority. So we want a number here, carbon 1, 2, 3, 4. Okay, because that give you the lowest number. Okay, 1, 2, 4. If your number this is 1, that will be 1, 3, 4. Okay, so the name will be 4 bromo, 2 chloro, 1 ethyl benzene. Okay, that's alphabetical order. Okay, B, C, E. Another example is phenol. Now this is the core phenol we just talked about, and we have a bromo group here. So carbon 1 will be here, 2, 3, 4, 5, 6. So that will be 3 bromo phenol. Another example is a toluene as a core, and you have a 3 nitro group. And number 1, because it's a toluene, 2, 3, 4, 5, 6. So the name will be 2,4,6 trinitro-toluene. And this is actually the TNT. TNT. Okay. Okay. A lot of important molecules or biological active molecules, they have a benzene as a core structure. For example, here, this is a medicine. It's called acetylsalicylic acid. You can see the core is here is the benzene and with the acid. So this is the benzoic acid. And this is aspirin. Okay. And the other medicine is here. The core is the phenol. Okay, with the amide bond here. And this is called the acetaminophen, and the more common is known as Tylenol. And here shows another biological active molecule. It's diol on the benzene, okay? And there's an amino group here. And so this is called 4. And this in parentheses is this 2 amino ethyl group at position 4. This is 1, 2, 3, 4. And then benzene, 1, 2 diol, 1, 2 diol. And this is dopamine, okay? So this is a very brief mini lecture about the naming of cyclic compound. If you have any more questions, please let me know. Okay, good luck.